3I Atlas didn't burn, it swallowed a solar flare. In late October 2025, the sun unleashed a massive eruption, a towering wall of fire and charged particles ripping out into space. Events like this can strip atmospheres, melt metal, and tear a spacecraft apart in seconds. Anything caught in the blast should have been destroyed. But not this time. Not with this object. When the flare struck 3I Atlas, it didn't vaporize. It didn't crack. It didn't even glow. It absorbed the impact cleanly, silently, as if a 4-kilometer body from deep interstellar space had opened its arms and consumed the breath of a star. That was the impossible moment. The moment every prediction, every physical model, every assumption simply failed. Because objects don't do that. Comets don't do that. Asteroids don't do that. Nothing we know behaves like that. And yet, 3I Atlas did. So the question becomes simple and terrifying. What kind of traveler takes in the fire of a sun and keeps moving? Tonight, we follow its path, where it came from, what we observed, and why its encounter with the sun may be the clearest sign yet that something entering our solar system is operating far outside the rules we understand. When astronomers traced the path of 3I Atlas for the first time, they expected something ordinary, a fragment of ice drifting quietly in from the outer dark, the kind of visitor our solar system encounters every few years. But the path didn't curve from the distant edges where comets sleep. It pointed inward, toward a place no natural wanderer should come from. And in that moment, a sense of unease settled over every observatory that saw the data. Something about this object was out of place long before we realized how strange it truly was. 3I Atlas was approaching us from the direction of the galactic center, a region dense with stars stacked so tightly that their combined light forms a permanent glow across the heart of the Milky Way. It is a chaotic environment where gravity twists violently, where dust clouds swallow entire star clusters, where ancient supernovae leave scars drifting through the dark. Nothing escapes that region easily. Even light struggles to carve a straight path through it. Yet here was an object, whole and intact, emerging from that deep and turbulent part of the galaxy. The galactic center is a furnace of creation. Stars are born in violent waves, then die in blasts that rewrite the structure of nearby space. Temperatures swing wildly. Radiation storms roll across entire systems. Planets form, break, reform, and collapse into their stars. It is not the kind of place where an object remains untouched. And yet, 3I Atlas bore no obvious marks of such violence. No fractures, no scars, no irregularities from ancient collisions. It drifted forward with a calmness completely at odds with the chaos it supposedly came from. Many scientists tried to attribute its origin to something simpler, perhaps a star had ejected it, or a gravitational interaction had flung it outward. But ejection paths don't stay clean across thousands of light years. Chaos leaves fingerprints, a twist here, a wobble there. Nothing about Atlas behaved like debris hurled into the void. Its path was a near-perfect line, consistent and unwavering, as if it had been traveling with intention long before humans ever thought to look its way. Imagine the journey, a 4-kilometer object drifting through the interstellar dark for millions of years, passing stars we will never name, skimming the edges of nebulae that shine like ghostly walls in the night, moving without hurry, without decay, without losing its shape. Most objects break apart over such distances. Ice sublimates, dust blows away, impacts are inevitable. But Atlas endured it all. The silence of that endurance unsettled many of the astronomers who studied it. Even the way it reflected light felt unnatural. Its surface was darker than expected, its glow muted, as if it absorbed more than it returned. Some speculated that the material composing it simply behaved differently, perhaps shaped by conditions near the galactic core. Others whispered that the object's strange darkness felt too deliberate, too consistent to be simple coincidence. In astronomy, darkness is data, and this darkness suggested a history we did not understand. As Atlas moved closer to the inner solar system, the questions multiplied. If it had truly come from near the galactic center, What force had given it the speed to travel this far? What environment had allowed it to survive intact? And more importantly, why did it arrive now during a period when the sun was growing increasingly active, building toward the solar flare that would later change everything? Scientists tried to avoid drawing connections. Coincidences happen. Timelines overlap. But privately, many admitted that the timing felt uncomfortably precise. The sun had entered one of its most volatile cycles in years. Telescopes were already watching for flares and eruptions. That was when Atlas appeared. Quiet, steady, and on a direct course into the region where the sun's magnetic tension was about to break. The deeper researchers looked into its trajectory, a stranger it seemed. Its path was not one of a rogue wanderer. It did not meander or drift. It carved through the solar system with a precision that felt wrong for something shaped by random forces. Even small gravitational nudges from the planets barely altered its motion. It held its line as if guided by something we could not see. Some began to wonder if Atlas was older than our current models could account for, if it was a relic from a system that no longer exists, a remnant of a place erased by time, pulled into the galaxy's core, remade, and then released again. Others wondered if it was something crafted not in the way we think of machines, but in the way nature itself sometimes sculpts impossibilities. A structure born in an environment so extreme that it carried properties unknown to our experience. Late at night, in quiet observatories lit only by screens, a different question began to surface. What if Atlas wasn't shaped by chaos at all? What if it had been moving on this trajectory for reasons we hadn't yet grasped? Not intelligence, not intention, not in any recognizable form, but a kind of long arc embedded in its existence itself, as if something far older than our civilization set it in motion long before our species even emerged. Still, the data resisted a simple narrative. Every natural explanation seemed almost right, but not quite. Every alternative seemed too bold to state in a formal paper. So the object remained suspended in uncertainty, a visitor from a region of the galaxy we barely understand, carrying with it more questions than answers. And as it continued inward, the tone of the scientific discussions shifted. No one dared call it artificial. No one claimed it was a probe. But no one, not even the most cautious researchers, could deny the eerie precision in its arrival. A precision that grew sharper with every passing day, as if Atlas were following a schedule we were only beginning to glimpse. The closer it drew to the sun, the stranger the alignment appeared. It approached not during a quiet period, but during a moment of rising tension within the star tension that would soon erupt into the massive solar flare it would later absorb. Whether that was coincidence or design, no one could say. But the universe rarely aligns such events without leaving the human mind unsettled. And so, 3I Atlas entered our solar system not as a comet or a fragment, but as a question carved into the darkness, a question about origins, about timing, and about the strange, quiet ways the universe sometimes delivers its messages. This was not just another object passing through. It was a reminder that the galaxy is vast, old, and capable of surprises we still have no language for. And, as its silent path carried it deeper into the light of our star, one final thought echoed through every discussion, every late-night analysis, every line of code trying to model the impossible. When scientists first measured the speed of 3I Atlas, they assumed the instruments were wrong. Interstellar objects move fast, yes, but this one moved with a steadiness that felt unnatural. Its velocity was too high for a body of its size, and too consistent to be the aftermath of a chaotic ejection. No tumbling drift, no erratic deviations, just a clean, unwavering motion through the void. Most natural objects carry scars of their journey. A gravitational nudge here, a chaotic spin there, tiny shoves from thermal radiation or the solar wind. Over time, even the most stable trajectories warp and bend. But 3I Atlas held its line as if the universe around it barely existed. It behaved like an object that answered to its own rules. What unsettled researchers was not just its speed, but its calmness. ATLAS moved with the kind of precision you would expect from a spacecraft, not a comet. Its rotation rate barely changed. Its brightness remained steady. It passed through regions of gravitational influence without reacting the way physics predicts. It was as though the object were insulated from the noise of space. Imagine a stone thrown through water. You expect ripples. You expect drag. You expect some sign that the environment is touching it. But Atlas passed through the solar system like a blade slipping through still air. No wobble, no sway. Not even the sun's pull seemed to rattle it. For many astronomers, that was the first real moment when unease turned into something deeper. The velocity itself was already unusual. 61 kilometers per second is fast enough to outrun entire planetary systems. Fast enough that even a small disruption could send it tumbling or tearing apart. But nothing touched it. Solar radiation pressure barely altered its curve. The gravitational fields of Mars and Venus shifted its path only slightly, like pebbles nudging a river that had already carved its way through stone. To understand how strange this is, imagine something traveling for millions of years. It should pick up rotation. It should pick up irregular motion. It should begin to scatter or crack. Yet Atlas behaved as if it had been launched yesterday. As if whatever set it in motion had done so with such force, such accuracy, that the universe had not yet found a way to reclaim it. Even the path it followed through the solar system felt unnatural. It sliced through the orbital plane of the planets at an angle too clean and too sharp to be coincidence. Jupiter, Mars, Venus, each lay near its projected route, spaced almost like markers on a map. The probability of that happening by chance was calculated at 1 in 250 million. Numbers like that do not comfort scientists. They provoke questions no one wants to answer on the record. Some argued that the trajectory might simply be a trick of perspective, a chance alignment that only looked purposeful from our vantage point. But the simulations told a different story. Even when the parameters were changed, mass estimates, shape assumptions, reflectivity models, the path barely shifted. Atlas was not wandering, it was traveling, and it was traveling along a line that felt traced. The longer scientists observed it, the more the object seemed to ignore the small pushes and pulls that shape normal interstellar debris. The Yarkovsky effect, solar tides, local gravitational perturbations, none of these left the imprint they should have. The object simply kept going with an almost eerie self-possession. It was the cosmic equivalent of a train locked onto rails. And yet, the strangest part wasn't its speed or its precision, but the sense of timing implied by both. It entered the solar system at the exact moment the sun was building toward a historic eruption. It crossed the inner regions at the exact moment our instruments were most focused. And through it all, it never behaved like an object uncertain of its path. Many astronomers stayed silent, unwilling to say aloud what the data suggested. They preferred words like unusual, anomalous, or unexpected. But the truth hovered in the back of every conversation. Natural objects do not move this way. They do not maintain this level of stability. They do not cling to a trajectory as if following an ancient instruction. There were other concerns as well. A few analysts noticed small but persistent patterns in its motion, micro-variations, too subtle for most to notice, yet consistent enough to suggest control. Not control in the sense of engines or thrust, but control like a sail adjusting itself to a wind we cannot detect. Something inside Atlas seemed aware of the forces acting on it, and something about those forces did not behave according to the physics we know. Night after night, the data became more puzzling. Even astronomers who resisted speculation found themselves staring at curves and graphs that refused to make sense. How could an object this large maintain a velocity this smooth? How could it hold a path this straight across such vast distances? What kind of material could resist spinning or cracking for millions of years? The questions multiplied, the answers did not. Some wondered if Atlas was much older than anyone assumed. Perhaps it had traveled not for millions of years, but for billions. Perhaps it had passed from one galactic arm to another, slipping through regions we barely understand. If that were true, then its path might not be coincidence at all. It might be the residue of a history far longer than our species has existed. Others suggested something even more unsettling, that the object had been moving along this trajectory since before the sun was born, that it had been set in motion during an era when the galaxy itself looked different, that its speed and precision were not signs of recent activity, but the preserved momentum of an act so distant that all memory of it has turned to dust. But the quiet question remained. If Atlas has been following this path for ages, why did that path lead here? Why now, in this cycle, during this flare, at this moment when we finally have the technology to see it clearly? Was this timing truly random, or part of a pattern we have not yet recognized? The deeper teams looked, the more the object resembled a message written in motion. A long, quiet line drawn across space, waiting for someone to finally intersect it. Perhaps not a message from intelligence, but a message from time itself. A reminder that not everything drifting through the galaxy is a remnant of chaos. Some things may carry a purpose older than our understanding. In every late-night discussion, every dimly lit observatory, every whispered thought no one wanted to publish, the same question lingered. It grew heavier as the object approached the inner planets. It grew sharper as its speed held steady. It grew undeniable as we realized that nothing about its journey resembled chance. For a long moment after the trajectory models came in, scientists believed the speed and precision of 3I Atlas were the most unsettling things about it. But that assumption would not last, because the next mystery, the chemical fingerprint of the object, was waiting quietly behind the data, and it would prove far stranger than its motion. Even as discussions grew heated about its impossible velocity, a more basic question was forming beneath everything. What was this thing made of? And why did its composition look like nothing we had ever seen? The transition from movement to matter happened slowly, almost naturally, as though the story itself wanted to shift focus. Atlas had come from an improbable direction and moved with an impossible steadiness. But direction and motion are only the surface of an interstellar visitor. To understand an object, truly understand it, you must read the light it reflects. Light carries memory. Light carries truth. And when the first spectroscopic readings of 3I Atlas were processed, that truth came back fractured, inverted, and deeply wrong. At first, the measurements seemed like errors. Instruments miscalibrate. Readings misalign. Dust can interfere. Every observatory team approached the data with skepticism. They ran controls. They recalibrated sensors. They repeated the sampling dozens of times. But the numbers did not change. The ratios held steady, no matter who observed them or which telescope collected the light. The signature simply did not belong to anything natural. Spectroscopy is simple in principle. When light from an object is split into its colors, the chemicals inside that object leave tiny gaps in the spectrum. Those gaps are like fingerprints. Every comet, asteroid, planet, and star has one. They are reliable, predictable, and universal. But 3I Atlas responded to the technique as though it had never heard of our rules. Its light came back with an inverted ratio of gases, flipped in a way that defied the chemistry of comets entirely. In every comet ever recorded, water vapor dominates. It is the backbone of their makeup. Carbon dioxide is present too, but always as a secondary component. In Atlas, the ratio was reversed. Carbon dioxide 8, water 1. The scientific community did not know what to do with that. Nothing in the catalogue matched it. Others suggested something even more unsettling, that the object had been moving along this trajectory since before the sun was born, that it had been set in motion during an era when the galaxy itself looked different, that its speed and precision were not signs of recent activity, but the preserved momentum of an act so distant that all memory of it has turned to dust. There were elements appearing in faint, whisper-thin traces, visible only on the most sensitive instruments. Nickel vapor hovered near detection thresholds. Cyanide appeared in soft, unstable bands, but the strangest line of all was the line that was not there. Iron was missing. The absence was so complete that most researchers dismissed it as a measurement flaw the first 3 times they saw it. Iron is everywhere, not metaphorically, literally everywhere. It forms in supernova explosions and populates galaxies with a kind of cosmic generosity. In our solar system, it is in meteorites, planets, dust, soil, and the cores of worlds. To see nickel without iron is like seeing smoke without fire. It does not happen in natural environments. So when the data insisted on zero iron, the reaction was disbelief, followed by discomfort, followed by something closer to fear. If the spectra were correct, and no one could prove they were not, then 3I Atlas had undergone some kind of process beyond simple cosmic wear and tear. Something had removed one of the most resilient and abundant elements in the universe. That was when a line from Richard Feynman began circulating in the quieter conversations. The original words were simple but haunting. Nature uses only the longest threads to weave her patterns, so that each small piece of her fabric reveals the organization of the entire tapestry. Many scientists repeated it not because they believed they had solved anything, but because the chemical signature of Atlas felt like a thread cut cleanly from a tapestry we recognized. Something was missing. Something had been taken out. The question that rose from this absence was unavoidable. Had the object experienced extreme filtering somewhere in its long journey through the galaxy? Had it been exposed to forces near the galactic center that stripped away iron while preserving nickel? The problem was that no known environment does this. Not black holes, not neutron stars, not star-forming regions. No natural process selectively removes iron and leaves everything else intact. Iron is durable. To erase it, something must work with power and purpose. And purpose is not a word scientists use lightly. But the more they studied the spectra, the harder it became to ignore the implication. If iron was gone, then something had taken it. If the ratios were inverted, then something had changed them. If the chemical fingerprint made no sense, then something had altered it in ways we did not understand. And that possibility sat in the back of every mind, like a quiet weight. What kind of environment could sculpt matter like that? What kind of process could rewrite an object's chemistry without destroying it? What kind of journey could preserve the shape of a body while changing its fundamental ingredients? Some researchers speculated about rare thermal conditions, exotic radiation storms, or collisions with ancient debris fields. Theories came and went, each collapsing under scrutiny. None of them explained the missing iron. Others wondered if Atlas was not shaped by environment, but by intention. Not a machine, not a craft, but a structure processed or refined long before it entered our solar system. Something once part of a larger form, something broken off or sent out. Something repurposed. The idea remained unsaid in public reports, but it lived in the pauses between sentences, in the hesitations during late-night video calls, in the tones of people who sensed they were standing at the edge of an answer that felt too large to touch. Still, the deeper truth was simpler. The chemical signature of 3I Atlas did not match anything. Not comets, not asteroids, not primordial debris. It was as if the object belonged to a category of matter we had never catalogued, a category that required us to rethink the boundary between the natural and the impossible. And so, the story of 3I Atlas shifted once again, from speed to composition, from direction to identity. Movement had opened the mystery, chemistry deepened it, and in that deepening, a new question emerged, sharper than the rest, haunting in its simplicity and its implications. Who, or what, removed the iron from this object before it arrived at our sun? For a long time after the chemical readings came in, the missing iron overshadowed everything. Scientists argued, speculated, recalibrated, and tried to rebuild some logical framework that could hold the impossible. But mysteries rarely arrive alone. They travel in clusters, each one leading quietly into the next. And as soon as researchers began to accept that Atlas was chemically wrong, they turned their attention back to something equally disturbing: its path. If the object already defied our expectations in composition, what did that say about the way it moved? How much of its journey was written in its chemistry, and how much in its direction? These questions flowed naturally, folding the story from matter back into motion. The line between them was thin, and the more astronomers explored it, the clearer one thing became. The trajectory of 3I Atlas was not just unusual, it was uncanny. Every object that wanders through the solar system tends to drift with a kind of cosmic looseness. Their paths curve under gravity, wobble under thermal effects, bend slightly as they pass planets. Even the most stable visitors show hints of ancient chaos. But Atlas did not drift. Its motion was too straight, too controlled, too aligned with something we could not quite name. The moment scientists plotted its entry path onto the plane of the planets, conversations changed. What should have been a broad, sweeping approach was instead a razor line that cut directly across the ecliptic. It did not weave. It did not arc clumsily through space. It sliced through the solar system as if guided by a ruler, with a precision that troubled even the most cautious minds. It passed near Mars in a way that felt almost deliberate. The alignment was sharp, the timing precise. Then it approached the orbital region of Venus with the same clean geometry, intersecting the planet's path at a moment so exact that the odds against it were staggering. Planetary scientists ran simulations again and again, expecting the numbers to smear into randomness, but the projections only reinforced the truth. The trajectory was too perfect to ignore. To describe this to the public, researchers had to soften the language. Words like intentional, structured, designed were kept off the record. Yet inside the observatories, behind closed doors, the tone was different. A few scientists admitted that Atlas looked less like a wandering object and more like a survey line, a line drawn across the solar system as if measuring it, testing it, observing it. One astronomer quoted Arthur Eddington, perhaps without meaning to reveal his unease. Something unknown is doing, we do not know what. The line was originally meant for quantum physics, not interstellar objects. But in the context of Atlas, it felt strangely appropriate, because its trajectory behaved like the handwriting of something we had not met. What made the path even stranger was its immunity to disruption. Jupiter, with its enormous gravity, normally pulls on passing visitors with subtle but measurable force. Yet Atlas barely reacted. Its line bent just enough to satisfy the equations, but not enough to feel natural. It was like watching a feather float through a storm without being touched by the wind. And then there was the timing. The object entered the solar system at the exact moment the sun was building toward the solar flare it would eventually absorb. If Atlas had arrived a month earlier, or a month later, it might have missed the event entirely. Instead, it approached the inner regions at precisely the right moment to meet the sun's eruption head-on. Some scientists dismiss this as coincidence. The universe is vast. Strange timing happens, but others felt the weight of it. The alignment of events felt too close, too sharp, as though Atlas were keeping a schedule. There was another layer to the unease. The object's line, through the ecliptic, was not just straight. It was centered, balanced, symmetrical in a way that made the solar system look like a diagram and ATLAS like the stroke of a pen across it. And when researchers stretched the line outward, projecting the same trajectory backward through space, it did not twist into randomness the way most interstellar objects do. Instead, it extended like a quiet arrow aimed from somewhere deep and ancient. The implications of that were unsettling. If Atlas had been traveling along a nearly perfect line for thousands or even millions of years, then the question was not just where it was going, it was where it came from, and whether this path was born out of chaos or intention. A few theorists suggested that the object might have been shaped by gravitational interactions long ago in ways we could not reconstruct. Perhaps some rare alignment of forces produced a vector so stable that it held its shape across cosmic time. The problem was that such a theory required an almost miraculous series of conditions, the kind of conditions that happen so rarely that the probability becomes indistinguishable from impossible. Others wondered if the object was following not a physical path, but a principle, something like a resonance with gravitational structures across the galaxy, something that nudged it into alignment without ever touching it. A subtle architecture hidden beneath the motions of stars and planets. But this idea was speculation layered on speculation. There was no evidence for such a mechanism, only the eerie line that Atlas carved across the sky. The most unsettling thought, though rarely voiced, was that the object's path resembled something purposeful, not necessarily driven by intelligence, but driven by pattern. a path too clean to be a fluke, too steady to be noise, too sharp to be chaos. In the silence of late-night analysis sessions, more than one scientist admitted that Atlas moved like a tool, a probe, a pointer, a measuring instrument, passing through the solar system as though collecting something we had not seen. Could an object measure a system simply by moving through it? Could its path be the imprint of a function, not an accident? These were questions no one wanted to ask publicly. The risk was too great, but the thought remained, because when an object crosses your planetary plane with the precision of a surveyor's line, you do not forget it. You do not dismiss it. You ask why, and you ask what, and you ask who. As Atlas continued its silent descent toward the inner sun, the idea became impossible to ignore. The solar system felt like a map, and Atlas felt like whatever drew the line across it. The ancient mystery of its chemical fingerprint had already cracked the door open. The trajectory forced it wider, and behind that widening door was a question that touched something deep and instinctive in every scientist who studied the data. Why did this object move with the elegance of intention? And if the line across our system was not random, then what was it? The solar system had been measured. The planets had been aligned along its path. The timing had been precise. The motion had been unwavering. So the question hung there, quiet and heavy, waiting for anyone willing to speak it aloud. For days after the trajectory plots were made public, discussion revolved almost entirely around the line 3I Atlas, carved across the solar system. A path too sharp, too straight, too precise. But, as astronomers traced that impossible line deeper into the inner regions of our star's domain, another detail started to surface quietly in the background. Something that seemed small at first, almost like an observational footnote. Yet the longer scientists looked, the more this detail grew into its own mystery. A mystery every bit as unsettling as the trajectory itself. Because Atlas was not just moving in a strange way, it was moving with an unnatural calmness, a silence so complete it made even seasoned researchers pause. When an object crosses into the solar system from interstellar space, we expect signs of stress. Interstellar travel is brutal. Radiation chisels away at surfaces. Micrometeorites strike with relentless frequency. Temperature swings are extreme. Most objects tumble as they move, wobbling from uneven heating or past impacts. They spin irregularly. They show brightening and dimming as different surfaces rotate into sunlight. But Atlas did none of these things. It did not tumble. It did not wobble. It did not brighten and fade in the way all irregular bodies do. Its rotation, if it had one at all, was too slow or too aligned for our instruments to detect. To the telescopes watching it night after night, it appeared almost motionless in its spin, gliding forward with a stillness that bordered on unnatural. The silence was not only in its movement, but in its behavior. Most interstellar objects release gas as they warm near the sunday. They vent vapor, produce faint jets, and shed material. Even Oumuamua, with its strange cigar shape, showed signs of outgassing that altered its path. But Atlas showed none. No jets, no venting, no trail of evaporated ice. Its surface remained dark and quiet, as if sealed against the heat of the sun itself. Scientists searched for explanations. Some suggested that the object was coated in a material that trapped heat instead of releasing it. Others thought it might be made of rock rather than ice, but these theories did not hold. If Atlas were rocky, its spectrum would show iron. It did not. If it were covered in insulating material, its reflection should shift as it warmed. It did not. And if it were releasing gas in ways too subtle to detect, its trajectory would show tiny deviations. It did not. The silence was total. At observatories across the world, astronomers found themselves staring at a body that behaved not like a natural object drifting into a new environment, but like something that had spent millions of years learning how to ignore the universe around it. It glided through the solar system like a silent arrow, its motion clean, its line unwavering, its presence stripping away the noise that usually accompanies visitors from the deep. One researcher, during a late-night review session, quoted Isaac Newton, without meaning to add weight to his own unease. He said, "Motion is the effect of impressed force." But Atlas moved as though no force had ever impressed anything upon it. Not gravity, not radiation, not impact, not heat. It was a body that seemed immune to the fingerprints of time. The silence was total. The deeper the analysis went, the stranger the implications became. If Atlas was not tumbling, then it was either perfectly shaped or perfectly balanced. Either scenario was rare. If its surface did not brighten as it rotated, then its rotation was aligned directly toward us, or was so slow that days passed before a full turn. Neither felt natural. If it did not outgas, then it either lacked internal volatiles or was sealed in a way that prevented release. Again, neither was satisfying. And yet, the data did not lie. Atlas remained perfectly calm. This calmness created new avenues of speculation. Some wondered if the object had spent most of its journey in a region too cold for rotation to build, but this did not explain its stability as it warmed. Others proposed that Atlas might be unusually dense, its internal mass distribution so balanced that it resisted perturbation. But that theory clashed with its strange chemistry. Heavy objects tend to contain iron, and this one did not. A more daring idea surfaced in private conversations. What if Atlas' calmness was not a byproduct of its composition, but a feature? What if the stillness was intentional, the way a well-crafted tool remains steady in a craftsman's hand? Scientists avoided this idea in public, but the thought lingered, especially after several teams noted that Atlas's albedo was far lower than expected, suggesting an exterior that swallowed light rather than reflected it. If the surface absorbed light, could it also absorb heat? If it absorbed heat, could it silence the thermal pressures that cause most objects to spin? If it silenced those pressures, could that explain the stillness? The logic was simple, but the conclusion was not, because absorptive surfaces do not appear by accident. They require structure, layering, intention. In the quiet hours of those early mornings, when data scrolled across screens in dim observatories, many researchers felt something they struggled to articulate. It was not fear. It was not fascination. It was recognition. A recognition that the universe was offering them a shape they had seen in theory, but never in reality. A body designed not to announce itself. Designed to move silently. Designed to minimize the chaos of travel. A body built for endurance. Some compared Atlas to a deep-sea creature, dark and still, adapted to pressure and silence rather than light. Others compared it to a seed, drifting on a cosmic wind, and a few, more reluctantly, compared it to a vessel. Not a ship in the way science fiction imagines one, but an object crafted to withstand time, heat, distance, and violence. Even those who rejected such ideas understood the weight of the silence, because silence itself can be evidence. A body that does not respond to heat suggests control. A body that does not outgas suggests containment. A body that resists rotation suggests a principle we do not yet grasp. What Atlas offered scientists was not a clear answer, but a shape, a silhouette carved from physics that did not belong to the universe as we know it. Something about its stillness pressed on the imagination, demanding a question no one wanted to speak with full confidence. Because how does an object several kilometers long move with the grace of something engineered? How does something older than civilization travel like a blade through emptiness? How does a mountain of material glide silently through a star system without shedding heat, sound, gas, or motion? These were not questions that fit neatly into research papers. They belonged to late-night conversations, to dim rooms, to hushed voices. Yet they persisted, circling the same unsettling truth. Atlas was calm, too calm, perfectly calm, and anytime nature gives you perfection, you must ask why. Because in the cold stillness of that object, in its refusal to tumble or shine or vent, there was a message carved into its behavior, a message written not in light, but in the lack of it. And it left scientists staring into the darkness of that silence, wondering what it meant. The stillness of Three-Eye Atlas lingered in every conversation long after scientists accepted that its silence was not an observational glitch, It forced them to rethink what a body drifting through the solar system was supposed to look like. Yet, silence alone did not define the object. It was only a doorway, a hint of something deeper. And anytime nature gives you perfection, you must ask why. In astronomy, almost everything has a category. When a visitor arrives from beyond the solar system, its shape, composition, motion, and brightness allow scientists to sort it into a familiar box. Comets carry water and release vapor as they warm. Asteroids reflect light in predictable ways and rotate unevenly. Debris fragments behave like the broken remnants of collisions. Even the two previous interstellar objects had their places. Oumuamua was bizarre, yes, but it still showed the traits of a fractured body reacting to sunlight. Borisov behaved like a more traditional comet, its gases forming a familiar tail, and as researchers moved from studying the calmness of its motion to analyzing the deeper patterns hidden in the observations, they realized the quiet was not an absence of behavior. It was a clue, because the more they listened, the more the data began to whisper something unsettling. Atlas did not fit anywhere. As the observations accumulated, the differences grew harder to ignore. Atlas did not rotate like Oumuamua. It did not outgas like Borisov. It did not scatter light in a way that matched any known mineral family. It did not carry the spectral signature of ice, rock, or metal in the proportions that define the comets and asteroids of our universe. Instead, it carried a fingerprint so mismatched that every existing category tried to pull it in, but failed. Some compared Atlas to a deep-sea creature, dark and still, adapted to pressure and silence rather than light. Others compared it to a seed, drifting on a cosmic wind, and a few, more reluctantly, compared it to a vessel. Not a ship in the way science fiction imagines one, but an object crafted to withstand time, heat, distance, and violence. It was as if the object wanted to be understood only by what it was not. Astronomers compared it to Oumuamua, searching for shared traits. Oumuamua's strange acceleration came from outgassing subtle vapor jets that acted like tiny thrusters. But Atlas had no jets, no vapor, no brightening, no trace of water or organic compounds. Oumuamua tumbled wildly as it passed the sun, but Atlas did not tumble at all. The stillness was its most defining feature. It behaved not like debris, but like a solid, coherent form. But Atlas stood apart from both. It mimicked neither of them. It rejected every label. Then scientists compared it to asteroids, hoping for common ground. But asteroids tend to carry iron. Many are metal-rich, many reflect light in predictable patterns, and nearly all of them display surfaces shaped by billions of years of collisions. Atlas carried none of those signatures. Its missing iron remained a central anomaly. Its surface behaved in a way closer to a light-absorbing shell than a rock carved by impacts, and its motion resisted the small disturbances that define asteroid behavior. Even the idea of a fragment from a destroyed world broke down under scrutiny. Fragments wobble, they spin inconsistently, they display irregular curves in their thermal readings. Atlas did none of these things. It remained steady, balanced, uniform, as if it were not a fragment at all but something complete. One astronomer described the problem bluntly during a closed panel. The data fits nothing in our taxonomy. Nothing we have seen behaves this way. And another, quoting Wolfgang Pauli, added the words that would later circulate quietly through the scientific community. This is not even wrong. It was meant as a critique of ideas that lie outside the realm of testable physics. But in the case of Atlas, it felt strangely literal. The object was not wrong. It was outside the frame entirely. This realization pushed researchers to consider deeper interpretations. Perhaps Atlas belonged to a category of interstellar bodies rarely observed, something born under extreme conditions, unlikely to appear near the sun except once in a cosmic lifetime. But even that theory struggled. Extreme conditions could explain its chemistry or its structure, but not both. And none of these conditions explained the absence of spin or the impossible steadiness of its path. Then came the quiet thought that scientists avoided putting into writing. What if the object did not belong to any natural family because it was not natural in the way we understand nature, not artificial in the sci-fi sense, not mechanical or technological, but something shaped or altered by processes that involved intention, a relic, a tool, a remnant of a structure whose purpose was long forgotten, not a machine, but something that had once served a function. Then came the quiet thought that scientists avoided putting into writing. What if the object did not belong to any natural family because it was not natural in the way we understand nature, not artificial in the sci-fi sense, not mechanical or technological, but something shaped or altered by processes that involved intention, a relic, a tool, a remnant of a structure whose purpose was long forgotten, not a machine, but something that had once served a function. This idea was not spoken loudly. No one wanted to be the first to cross that line, but it lived between the lines of conversations, behind paused breaths and unfinished sentences, because every piece of data pointed in the same direction. Atlas was not behaving like a random object. It was behaving like something with coherence and history. The deeper scientists looked, the clearer the whisper became. Atlas was not like anything we had catalogued. It did not behave like a comet, an asteroid, a fragment, or a shard from a broken world. It carried a chemical profile without precedent, a motion without wobble, a trajectory without chaos, a silence without explanation. The data did not shout its truth, it whispered it. Through the stillness, through the missing elements, through the path too straight for nature, through the reflection too dark for rock, through the stability too perfect for chance. And when an object whispers, the human instinct is to lean closer, to listen harder, to ask what lies behind the quiet. This realization pushed researchers to consider deeper interpretations. Perhaps Atlas belonged to a category of interstellar bodies rarely observed, something born under extreme conditions, unlikely to appear near the sun except once in a cosmic lifetime. But even that theory struggled. Extreme conditions could explain its chemistry or its structure, but not both. And none of these conditions explained the absence of spin or the impossible steadiness of its path, a question that grew heavier with every new measurement, every new model, every new night of observation. If it does not belong to any group we know, then what is it? In the hours following the realization that 3I Atlas fit no category in our scientific vocabulary, something quietly shifted in the tone of the conversations happening in observatories around the world. The data had already pushed astronomers into unfamiliar territory. They had eliminated every known family of interstellar objects. They had dismantled every natural model that was supposed to explain how something forms, moves, and behaves in deep space. And yet 3I Atlas remained intact, untouched by any explanation we could offer. It was in this uncertainty, in the quiet room between conclusions, that another idea began to take shape. It did not arrive with confidence, it arrived with hesitation, with caution, with the kind of whisper people speak only when they know the words might reshape everything. The deeper scientists looked, the clearer the whisper became. Atlas was not like anything we had catalogued. It did not behave like a comet, an asteroid, a fragment, or a shard from a broken world. It carried a chemical profile without precedent, a motion without wobble, a trajectory without chaos, a silence without explanation. When every natural mechanism fails, the human mind reaches for other possibilities, not because it wants to, but because curiosity demands it, and the universe itself pushes us toward the questions we try hardest to avoid. The first scientist to voice the forbidden thought did so late at night, after staring at simulated models for hours. The recordings from that session are quiet, filled with the sound of keyboard taps and long pauses. Then a single line, "Maybe this is not natural." The words hung in the air, unanswered, not contradicted, just suspended, waiting for someone else to acknowledge that they too had been thinking the same thing. This whisper grew naturally from the frustration of classification. Scientists pride themselves on identifying patterns. Biology has taxonomy. Geology has mineral families. Astronomy has object classes shaped by decades of observation, but Atlas refused all of them. It was the culmination of mismatches, too still to be debris, too exact to be random, too dark to be rock, too stable to be an icy fragment, and too orderly in its internal behavior to be chaos frozen into a shape. It forced them to reconsider foundational assumptions about what nature could and could not do, because the truth was simple. If Atlas was natural, then nature had done something we had never seen, something unprecedented, something that violated the expectations built over a century of astrophysics. And as one researcher quoted Carl Sagan, repeating the line exactly the way he wrote it, "Extraordinary claims require extraordinary evidence." Yet the evidence that Atlas was natural was beginning to collapse, while the evidence that it was constructed, or shaped, or altered by some process beyond randomness was quietly mounting. This did not mean a machine. It did not mean technology. It did not mean intention in the human sense of the word, but it did suggest a possibility that lay somewhere between the organic and the engineered, a category we have no name for, a structure that might have been built by natural processes so rare they appear artificial, or by artificial processes so ancient they appear natural. Some scientists wondered if Atlas might be a remnant of a civilization long vanished, not a ship, but a fragment, a broken piece of a megastructure, a shard of something larger that once drifted between stars. Others believed it could be an object crafted with a purpose we do not yet understand, left to wander across the galaxy for millions of years. Still, others proposed a more conservative idea, that Atlas might be a kind of cosmic artifact, a body sculpted by extreme forces near the galactic center, where gravity and heat can create shapes that mimic intention. But even the conservative theories sounded bold compared to traditional astronomy, because in every scenario, the object was no longer simply born, it was shaped. More data began to reinforce this uncomfortable possibility. The missing iron, the perfect silence, the impossible trajectory, the stable velocity, the dark, absorptive surface, the inverted chemistry. None of these matched known processes. Put together, they formed a pattern, and patterns demand interpretation. Over the next few days, similar comments began to surface, never in official reports, but in hallway conversations, hushed exchanges during breaks, scraps of speculation shared over coffee at 2 a.m. These scientists were cautious, almost apologetic. No one wanted to jump to something extraordinary. No one wanted to make claims that would damage reputations or distort the truth. But the inability to categorize Atlas pressed on them in ways they could not ignore. Still, the scientific community hesitated. They knew what happens when speculation outruns evidence. They had seen excitement distort judgment before. They had seen imagination cloud objectivity. So, they walked a tightrope, 1 foot in caution and 1 foot in possibility. They did not claim design, they did not deny it either. They treated the idea as an open question, waiting for the universe to provide more information. Inside observatories, the atmosphere grew tense, but not fearful. It was something else, a sense of standing at the threshold of a discovery that might rewrite our understanding of cosmic history. If Atlas was shaped by something, then every assumption we hold about life, intelligence, and time in the universe would need to be re-examined. Not because Atlas was alive or piloted, but because intention is a property, a signature, a trace left behind by order. And order without natural cause is the closest thing to a message the universe can send. Scientists began asking quiet questions. If Atlas is shaped, is it a relic or a tool? If it was constructed, who constructed it? If it served a purpose, what purpose could endure across millions of years? And if it was sent with awareness, or was it simply released like a seed into cosmic winds? One astrophysicist, trying to articulate the unease, quoted Freeman Dyson, using his original words, "Look for what is detectable, not for what is probable." It was a reminder that scientific truth does not bow to human expectations. It appears where the data points, and the data pointed towards something no one had considered 10 years ago, something crafted, in some sense of the word, and although no one wanted to say it with certainty, the implication grew too large to hide. Maybe, just maybe, Atlas was not a stone. Maybe it was a structure. That idea did not require aliens. It did not require science fiction. It only required acknowledging that intelligence could exist elsewhere and long ago, and that its artifacts might drift through the galaxy long after its makers were gone. The universe is old, older than our world, older than life on Earth, older than our imagination, and in an ancient universe, the idea that something crafted might remain after its creators vanish is not extraordinary, it is inevitable, which leads to the question that finally rose from the whispers, a question as large as the object itself and as quiet as its passing through our sky. If Atlas was created, shaped, engineered, or altered, then it must have had a purpose. When the whispers about design grew too persistent to ignore, scientists found themselves in an uncomfortable place. They stood between evidence and imagination, unable to deny what the data suggested but unwilling to declare it outright. That tension, fragile and electric, defined every discussion surrounding 3I Atlas. Yet even that tension, gripping as it was, would soon be dwarfed by what happened next, because while researchers debated the object's nature, the Sun was preparing an event that would push the mystery of Atlas from speculation into something far more profound. And as the object continued its measured, silent glide toward the inner solar system, the universe seemed to arrange a meeting that no one would have believed if not for the instruments that recorded it. The Sun has moods, cycles of calm and storms, long arcs of magnetic tension that build quietly beneath its surface. Solar physicists had been watching those tensions rise for weeks. They saw the twisted magnetic fields, the growing knots of energy, the ultraviolet flickers spreading across the corona like veins of heat. It was the prelude to a major event, the kind that only happens when the Sun's internal forces snap and hurl matter into space with unimaginable violence. Solar flares of this scale are rare, but not unheard of. They release billions of tons of charged particles, radiation, and plasma. They can disrupt satellites. They can damage power grids. They can strip atmospheres from planets if the geometry is right. And in October of that year, the geometry was perfect. A coronal mass ejection erupted from the Sun with the force of a stellar exhalation. It was enormous, one of the largest in decades. A wall of plasma moving at millions of miles an hour, a tidal wave of fire traveling through a vacuum. And because of the precise, razor-line trajectory Atlas followed, the two paths were set to intersect like clockwork. Most astronomers expected a spectacle. An object, even a large one, cannot survive a direct hit from a CME without reacting. A comet would burst into vapor. A rocky asteroid would fracture from the sudden heating. Even spacecraft, coated with protective shielding, would be damaged beyond operation. The energy involved was simply too extreme. Nothing absorbs the blast of a star and remains whole. So, as the CME hurtled toward 3I Atlas, telescopes across Earth and in orbit prepared to record its destruction. They tuned their sensors. They adjusted their exposures. They waited for the burst of light that would mark the end of what was already one of the strangest objects ever observed. But the burst never came. Instead, something else happened. Something no one thought possible. When the CME struck, Atlas did not shine brighter. It did not glow. It did not scatter material into space. Its trajectory did not shift. It behaved unlike any known object in the solar system. The wave of solar energy hit the surface, and then it vanished, not reflected, not deflected, not transmitted, absorbed, completely. Energy conservation is a principle so fundamental that many physicists treat it as a law of nature itself. Yet here was an object swallowing the energy of a star without leaving a visible trace. One researcher, stunned into silence, later quoted Arthur C. Clarke, speaking the line exactly as it was written. Any sufficiently advanced technology is indistinguishable from magic. He did not say the word technology again after that. He did not need to. Because what 3i Atlas did in that moment did not feel like magic. It felt like intention. Even the instruments seemed confused. Radiation levels dropped abruptly in the space just behind the object, as if Atlas had carved a cavity of calm inside the storm. The CME behaved as though it were being consumed, pulled inward, reduced into something ordered. Scientists searched desperately for signs of heat release. They expected infrared spikes. They expected thermal shock. They expected something, anything, that would indicate where the energy had gone. They found nothing. So, as the CME hurtled toward 3i Atlas, telescopes across Earth and in orbit prepared to record its destruction. They tuned their sensors. They adjusted their exposures. They waited for the burst of light that would mark the end of what was already one of the strangest objects ever observed. The implications were immediate and overwhelming. If Atlas had absorbed the CME, then it possessed a structure capable of interacting with electromagnetic energy in ways humanity had never achieved. Not shielding, not deflection, actual absorption, complete intake, and not only the visible wavelengths, but the charged particle storm as well. This raised a new set of questions, deeper and sharper than those that came before. Did Atlas convert the energy internally? Did it store it? Did it channel it? Or was this something else entirely? A property of its material that we have no name for? Could it be some exotic phase of matter? A plasma-bound lattice? A superconducting shell with a capacity far beyond anything engineered on Earth? But even these ideas faltered. They were scaffolding built around ignorance. Attempts to describe something that fit no model. Something that defied natural formation. Because nature does not build things to swallow stars. And time does not preserve objects capable of ignoring heat at this scale. What happened after the impact only deepened the puzzle. Several observatories recorded a shift in its velocity. A subtle increase. Smooth. Controlled. Not explosive. Not reactive. It moved as if the absorbed energy had been translated directly into motion. Not by force. Not by thrust. By conversion. Purposeful, steady conversion. This was the moment when hesitation shifted into fear. Not panic, but the quiet, heavy kind of fear that comes from realizing the universe is larger and older and stranger than we allow ourselves to imagine. Atlas was no longer just an object moving through the solar system. It was something capable of interacting with a star like a living system accepts fuel. Researchers who once whispered about design now found themselves staring at data that demanded the question be taken seriously. Because if Atlas was natural, then nature had invented a mechanism as sophisticated as any technology we could dream of. And if it was not natural, then the history of the galaxy might contain chapters we have never read. The CME event marked a pivot not just in observation, but in understanding. Atlas had met a star's fury and responded not with destruction, but with calm. It absorbed the chaos. It stored the fire. It turned a disaster into motion, which leaves only the question that hovered over every lab, every meeting, every sleepless night spent staring at the data. A question as undeniable as the event itself. In the hours after the CME event, when 3i Atlas absorbed the fury of the sun and emerged untouched, astronomers expected the story to settle into analysis. They thought the next chapter would be slow, methodical, defined by cautious interpretation and careful debate. But the universe had a different plan, because just as the shock of the absorption began to fade, a new anomaly appeared, one so delicate that it almost escaped notice, one so subtle that it took multiple observatories comparing their data to confirm it. Yet once confirmed, it eclipsed everything that came before. The object had begun to accelerate, not violently, not sharply, not like something being pushed. The shift was smooth, gradual, almost graceful, but it was unmistakable. The velocity curve bent upward. The numbers drifted free of prediction. Atlas was moving faster, faster after the flare than before. And not because of solar pressure or gravitational slingshot effects. Those processes leave signatures. They leave heat, they leave radiation, they leave measurable shifts in trajectory. Atlas left nothing. It accelerated as though a switch had been flipped inside it. Acceleration in space requires force. That is one of the simplest principles in physics. To go faster, something must push or pull. Rockets burn fuel. Gravity wells slingshot spacecraft. Solar sails catch photons. Even natural objects accelerate through chaotic interactions. Yet Atlas showed no thrust, no reflection spike, no plume, no heat, no debris release. Nothing that resembled the exchange of momentum. It simply gained speed, silently and cleanly, like a thought moving through the void. The first reaction among researchers was disbelief. They checked for solar wind effects. They checked the error margins of their instruments. They checked for dust trails. They checked for mass loss. They checked anything that could explain the motion. But everything returned null. The object was accelerating without interacting with its environment in any measurable way. To an astrophysicist, this is like watching someone climb a staircase without touching the steps. Several panels convened within hours. Scientists ran through every natural explanation they could imagine. Some proposed the CME had stripped material from Atlas in a way too subtle for detection, reducing its mass and allowing the remaining body to travel faster. But this theory collapsed immediately. Telescopes recorded no mass reduction. Others suggested the CME temporarily altered the object's thermal profile, causing radiative effects that nudged its speed. But no heat output was detected, no temperature spike, no thermal gradient. A more imaginative theory suggested magnetic coupling between Atlas and the flare, a kind of interaction between charged particles and surface material. But again, the data failed to show any of the necessary signatures. Even at its most creative, the scientific community could not find a natural mechanism that produced acceleration without byproducts. This is why one physicist, speaking at a small roundtable discussion, quoted a line from Richard Feynman that hung in the room like a verdict. The first principle is that you must not fool yourself, and you are the easiest person to fool. It was a reminder that extraordinary events require humility, but it was also a statement of frustration, because no one could find a way to reconcile the acceleration with nature as we understand it. Once denial faded, another possibility came into focus. Perhaps Atlas did not absorb the CME passively. Perhaps it used that energy, converted it, stored it, released it, internally, in a controlled way. Not like a reactor, not like an engine, more like a system designed to harvest radiation on a scale beyond anything humanity has attempted. Something that could take the chaos of a star and translate it into ordered motion without losing heat or emitting waste. It was an unsettling idea because it implied the object was not merely surviving the flare, it was feeding from it. The first reaction among researchers was disbelief. They checked for solar wind effects. They checked the error margins of their instruments. They checked for dust trails. They checked for mass loss. They checked anything that could explain the motion. But everything returned null. The object was accelerating without interacting with its environment in any measurable way. A few engineers suggested a concept that normally exists only in theoretical labs. If Atlas possessed an internal lattice of superconducting materials, it might be capable of channeling electromagnetic energy with almost no loss. In theory, such a system could store enormous amounts of power. In theory, it could even convert that power into motion. But superconductors of that scale do not survive space. They require temperatures and conditions that the universe rarely provides. They break, they decay, they shatter, yet Atlas did not. Others proposed the idea of exotic matter phases, materials shaped under conditions near black holes or neutron stars. In such environments, matter may behave in ways that seem impossible elsewhere. But every version of this theory ran into the same barrier. Exotic matter does not produce perfect silence. It is unstable. It decays. It interacts. And Atlas interacted with nothing. A more uncomfortable question began to surface. What if Atlas was designed for this? What if absorbing stellar energy and turning it into motion was not an anomaly but a function, a built-in capability of a structure older than Earth itself? A kind of interstellar metabolism, not biological, not conscious in the way we think, but purposeful. A machine without mechanics, a vessel without engines, a traveler that feeds on stars the way ancient creatures fed on the sea. Scientists resisted this idea. They worried it would ignite public speculation. They worried it would distort the truth. But privately, many admitted the same thought. The acceleration looked too clean to be incidental, too elegant to be accidental, too precise to be the side effect of something else. A more imaginative theory suggested magnetic coupling between Atlas and the flare, a kind of interaction between charged particles and surface material. But again, the data failed to show any of the necessary signatures. Even at its most creative, the scientific community could not find a natural mechanism that produced acceleration without byproducts. And that slope carried implications too profound to ignore. Because once acceleration begins, another question emerges. Acceleration toward what? The sun? A slingshot maneuver? A distant target? Or perhaps nothing specific at all, just a continuation of a journey that began millions of years ago, picking up energy wherever it can, drifting between stars like a seed searching for light. And that slope carried implications too profound to ignore. Because once acceleration begins, another question emerges. Acceleration toward what? The sun? A slingshot maneuver? A distant target? Or perhaps nothing specific at all, just a continuation of a journey that began millions of years ago, picking up energy wherever it can, drifting between stars like a seed searching for light. By the time the scientific community accepted the data, something else had shifted too. The object no longer felt like a puzzle of chemistry, or trajectory, or silence. It felt like a traveler with rules we did not understand. A traveler that had endured distances we cannot fathom. A traveler that may have been shaped by forces or minds long vanished. And as the acceleration continued, the mystery sharpened. Because once a body eats the fire of a star, and once it translates that fire into motion, there is only one question left to ask. When 3I Atlas slipped behind the sun, the light swallowed its silhouette, and the instruments began to lose their grip on it. Bit by bit, the data thinned. The signals weakened. What had felt so close, so present, so sharply defined in our measurements, now faded into a haze of static and uncertainty. It was as if the object had stepped into a doorway between what we can observe and what we can only wonder about. And on the far side of that doorway, our theories began to fall apart. Every model built over months unraveled as the numbers flickered out. Every confident interpretation dissolved. What remained was not clarity, but a kind of quiet, a reminder that in the face of something vast, our understanding is only a candle held up to an ocean of darkness. As data from multiple observatories poured in, the velocity increase became impossible to dismiss. Atlas was not just moving, it was moving with intent embedded in its behavior, though not necessarily in intelligence. Its speed rose with a smooth, controlled slope, like a graph drawn by a steady hand. The object will emerge again from behind the Sunday. We will study it. We will measure it. We will try, once more, to bring it into the circle of things we understand. But some part of us already senses the truth, that every time we look into the dark looks back. And so the final question lingers, soft but unshakable. If Atlas truly is a traveler, then who or what was it meant to find? If you want to keep following this journey into the unknown, feel free to stay with us. The universe is only getting stranger from here.